Now learning physics will be great fun with a physics teacher, a solution to all problems in physics.
The physics teacher.
In this problem, we have to find the speed of 10 kilogram block at the end of 6 seconds. So here we have the situation in which a 10 kilogram block is placed over a 20 kilogram block. A force F is equal to 5T means this is a variable force that is acting on this 10 kilogram block. The surface between this 10 kilogram block and the 20 kilogram block is frictional, having a coefficient of friction 0.2, and the surface below this 20 kilogram block is frictionless as mu is given 0. So in such a problem, most of the times students start this problem as that F is equal to Ft, means this force is variable, and the force of maximum static friction between the 10 kilogram block and the 20 kilogram block is mu, coefficient of friction, into normal reaction. Normal reaction of 10 kg block on the 20 kilogram block is 100 Newton. Clear? So the force of maximum static friction comes out to be 20 Newton. Now the students are tempted to solve this problem with the inference that as soon as this applied force F is equal to 5T becomes more than, if this force becomes more than the force of maximum static friction, they assume that this 10 kilogram block comes to a relative motion with respect to this 20 kilogram block, and this is a fact also. But we have to check in this situation that whether this force of maximum static friction comes into play between this 10 kilogram block and the 20 kilogram block, because as per the definition of the friction comes into play whenever there is a relative motion between the two surfaces. Now of what degree this relative motion is between this 10 kilogram and the 20 kilogram block will decide the nature of friction between the two blocks. As long as the force between these two blocks of 10 kg and the 20 kg remains less than the force of maximum static friction or equal to force of maximum static friction, these two blocks will keep on moving together. So the main thing here you have to consider is that whether the force between the blocks reaches FMS or not. If the force between these two blocks does not reach FMS, so there is no relative acceleration of this 10 kilogram block with respect to 20 kilogram block, and in such a situation both the blocks will move together with a common acceleration. Clear? So in order to solve such kind of problems, what is the approach is that you have to choose a block which moves only because of friction. So here the block which moves only because of friction is the 20 kilogram block. How? Because when you apply a force F on the 10 kilogram block, this 10 kilogram block has a tendency to move relative to this 20 kilogram block, and the motion of this 10 kilogram block is retarded by the 20 kilogram block in this manner. So we can understand this by drawing the free body diagram. So this is the applied force, and the force of maximum static friction, or you can say the force of friction, will act in this direction, and the force of friction on this 20 kilogram block is acting in this direction. Now we are assuming that this force acting on this 20 kilogram block is a force of maximum static friction, so that we can calculate the maximum acceleration that can be achieved by this 20 kilogram block. So FMS here we have 20 Newton. The mass of this mass of the lower block is 20 kilogram. So we have 20 Newton divided by 20 kilogram. So we have 1 meter per second square. So that is the maximum acceleration that can be achieved by 20 kilogram block that is moving only because of friction. Clear? Now as we have calculated that the maximum acceleration achieved by this 20 kilogram block is 1 meter per second square, means up to this situation of achieving the maximum acceleration by 20 kilogram block, both of the blocks of 10 kilogram and the 20 kilogram are supposed to be moving together, because this is the force of maximum static friction that has just arisen because of this applied force. So for this situation we try to figure out that what is the value of F, this F, to produce 1 meter per second square as the common acceleration between these common acceleration of both these blocks. So if we assume that the applied force has just created an acceleration of 1 meter per second square acceleration in this block of 10 kilogram also, so applying Newton's law, we can see that F minus FMS is equal to mass into acceleration, and we know that F minus FMS is 20 Newton and 10, so this gives us F is equal to 30 Newton. So our illusion that if this force F, which is 5T, is 20 Newton, then FMS is also 20 Newton. So this is not the case here. You can see clearly that on application of 30 Newton force, FMS is 20 Newton. Clear? So this is the most important point you have to look here, that the lower surface has also, or the lower surface is also in motion along with the upper surface. So in order to have a maximum static friction on the lower block, we have to apply 30 Newton force on the upper block. So suppose this is the 30 Newton force that is acting on the upper block. Now at what time this 30 Newton force comes into play? So you can calculate F is equal to 30 Newton, and from the given situation you can clearly see that at t is equal to 6 seconds, at t is equal to 6 seconds, this force of 30 Newton comes into play. And what we have been asked, that we have to find the speed at 6 seconds. This means the blocks are moving together with common acceleration up to 6 seconds. Clear? Means up to 6 seconds both the blocks have no relative acceleration with respect to each other. So this is most important point we have to look after here in this problem. Clear? Or you can understand this problem in another way also. Suppose this is 20 kilogram block and this is the 10 kilogram block. This is 10 kilogram block, this is 20 kilogram block, and a force 5T is acting on the system, suppose. Now unless the force here between the blocks, unless here the force between the blocks is FMS, means unless the force here between the blocks reaches FMS, both the blocks have a common acceleration. So the common acceleration of the blocks is the applied force divided by the mass of the system. So it gives us T by 6. Clear? Now just consider the lower block, that of 20 kilogram, and assume that at time t, at time say t, the force of maximum static friction comes into play. At time t, we don't know what is that time, but the force of maximum static friction, that is 20 Newton, has reached. Clear? Now the force has reached to 20 Newton at this time, and in this situation the acceleration of this 20 kilogram block is 1 meter per second square, and that is the maximum acceleration that can be achieved by this 20 kilogram block. Now, as I have told you, that unless the force here reaches this FMS, both the blocks are assumed, or both the blocks will move together. So FMS has just reached, that is 20 Newton, and in this situation the acceleration is 1 meter per second square, and that acceleration is also the common acceleration at this time t. So if I use this result, that t by 6, this common acceleration, is equal to this acceleration, this means the t, this time is 6 seconds. So again we have proved that the blocks are moving together up to 6 seconds. As the blocks are moving together, so they have common velocity also in this situation up to 6 seconds. So in order to find that common velocity, we have this result, acceleration is equal to t by 6. From here you can see that acceleration is t by 6, or you can write dv by dt is equal to t by 6, or dv is equal to t by 6 dt, and integrating both sides, taking the limit from 0 to 6 seconds, velocity is 0 to v, and that v is common. So from here we can write v equal to t square by 12, and taking the limit from 0 to 6. So from here you can have v is equal to 3 meters per second. Clear? So the answer is B, 3 meter per second. So I am repeating the situation here again in order to have a clear understanding that in such problems you have to first look whether there is relative acceleration between the blocks has arisen or not. Clear? So long as there is no relative acceleration between the blocks, they will have definitely common acceleration, and for that you will look for the force required to produce that maximum acceleration in the block that is moving only because of friction. Now that factor will decide that whether there is relative acceleration or not. Clear?